Hi everyone, this is Mrs. Bustamante, and in this video we're going to be talking about 8.5, which is all about community ecology. So we're going to talk about how populations interact with each other, and then we're also going to talk about something called the Simpson's Diversity Index, which really just tells us a way of kind of mathematically calculating or stating how diverse a particular population is. Let's go ahead and get started though by really just talking about what is a community, right? We talked about populations are groups of individuals of the same species, right? So a community is a group of different species living together in the same location and interacting with one another. Another way to think about that is they're populations of different species interacting together in the same space, typically kind of at the same time, but right, we know that there are different types of the day when we can see different organisms be active and fulfill kind of their roles in a given situation, right? So if we look at this and we go big to small, we can see an organism is the smallest, a population, a group of like organisms, if you will, that interbreed. Then we have a community. Those are all the populations within that particular space that would make up your ecosystem, right? And eventually your biospheres, your global processes. So we can talk about, or rather describe, our community based in a couple of different ways. In this particular section, we're going to talk about describing our community based on the diversity of it, really the species diversity, and then the species composition of it. So what's species diversity? Well, we're looking at species, so things that would intermate, in diversity, or variety is kind of a way to think about it. So species diversity is the variety of species and the quantity of individuals included in each species within a given community. So, for example, when we're looking here, we see one species of moose and one species of owl. Okay, those would be our species. But then if we went on to talk about, well, maybe there are 15 moose in that particular area and there are 3 owls in that area, that would be describing species diversity. We're talking about what species are there and then how many of them are present. Species composition, on the other hand, is just the identity of each species in the community. So that'd be just like giving the specific names of different species in, say, this community we were looking at here. Notice it's not talking about the number of each type of species in there. So a lot of times we can just look at data and say, or look at a place and talk about its diversity. Everything either kind of looks the same or doesn't look the same, or we see lots of different things, or mostly one species and just a couple in there. And we can actually kind of, probably most of us, intuitively make some conclusions about diversity in a given area. But what if we want to be more quantitative, right? Less subjective. We can use something called the Simpson's Diversity Index, and it's really just a method of measuring species diversity. Okay, the higher the index value, we say, the more diverse or biodiverse our community is that we're looking at, right? So if we went out and we surveyed some part of land and we just counted how many of different types of species we saw in, say, like a given space, and then we brought that back and we tried to calculate it and use it, right? The higher the index, the more likely that if you were to select any 2 individuals randomly, right, from that population, that they would not be from the same species, okay? So a higher number basically means more diverse. So when you solve this, right, if you look at area 1, so I just put diversity index of 1, and you got 0.76, that'd be like 76%. There's a 76% chance that you could grab any 2 species and they would be different from each other. On the other hand, here's a diversity index of, say, area 2, probably the same amount of space, just things we're comparing, and we got 0.43. That'd be like saying 43%. So area 1 would be more diverse than area 2, right? So here is your Simpson's Diversity Index equation, okay? And yes, it's listed on College Board, on your form when you go to take the AP test. It says the diversity index is equal to 1 minus the summation of little n, which is the total number of organisms of a particular species, divided by the total number of organisms of that species, and then squared. So we're going to walk through an example here in a second But basically what that means is that we're going to look at each individual species kind of on its own, but then we're going to add them all together, right? That's what this summation part means for us here. Let's go ahead and look at an example. I just kind of made this up, okay? What is the diversity index of a square kilometer that contains 5 anteaters, 100 beetles, 10 monkeys, and 2 sloths? Okay, so first, what do I want to do? I want to figure out what big N is, and that's my total number of species. So all I do is I take 5 plus 100 plus 10 plus 2, and I add them all together. And when I add them all together, that gives me N is 117. That means I counted 117 different organisms, okay? Now, my diversity index tells me, equation rather, tells me I take 1 minus the sum of the total number of species divided by, of a particular species divided by all species squared. So here's what that looks like. I do 1 minus, I put brackets because I'm going to do everything inside of this bracket first. These parentheses, well, my first one, there are 5 out of 117. I square that value, plus there are 100 beetles divided by 117. Remember, do this division first and then square it. There are 10 monkeys out of 117 total organisms, so do 10 divided by 117, then square it. And then do 2 divided by 117 for my number of sloths and square it. Okay, that'll give you lots of decimals here. Notice I left them in the brackets following our order of operations. Okay, so I'm going to do 1 and then I'm going to take 0.002 plus 0.73 plus 0.007 plus 0.0003. And I'm going to add them all together. Now, here's a point I always like to check. Does my answers make sense, right? This number here should be bigger than this one that was the smallest and so forth a little bit, right? Okay, when I add these all together, I get 0.739. So I take 1 minus 0.739. That means my diversity index is 0.261, or about 26%, right? And that's with only 4 species, which kind of interesting to think about, right? So this means that the probability that 2 individuals randomly selected from this sample would actually belong to different species is only about 26.1%, right? Which isn't that high compared to some areas, but it's kind of interesting to think about when there were only 4 different species in this particular area that got surveyed. So that is Simpson's diversity index. It gives us a way to kind of quantitatively discuss the biodiversity in a given area, and I hope that was helpful.